In crisis response, time isn't just money, time is trauma. Frontline NGO workers run their operations on Slack, but the data lives in a chaotic web of Airtable bases and Google Sheets. The National Alliance to End Homelessness reports that intake and placement decisions can take up to 6 hours when multiple systems are involved. And the Urban Institute found that coordinated entry systems average over 3 failed referrals before a successful placement. We call this the context tax. But there is a darker problem with applying AI to crisis response. LLMs hallucinate physical reality. Microsoft research demonstrated that even the best LLMs fail nearly half the time on basic physical reasoning tasks involving height and weight and volume. If a generic AI bot hallucinates that a standard passenger sedan can fit a 350-pound motorized wheelchair, a vulnerable person is stranded on the street. And social impact and AI hallucination isn't just a bad course suggestion, it's a failed rescue. To solve human trauma, we cannot rely on probabilistic guessing, we need mathematical certainty. Lifeline is a neurosymbolic dispatch engine. The core innovation is the strict separation of language from physics. We recognize that large language models are language engines and not physics engines. So we strip the LLM of its ability to guess physical constraints. Instead, we built a discrete physical ontology hosted inside a dedicated model context protocol server. MIT Computer Science and Artificial Intelligence Lab has proven that neurosymbolic methods, such as this one, combining neural perception with symbolic reasoning, achieve over 90% accuracy on physical benchmarks compared to 60% of pure neural approaches. We are applying the exact same principle here. When Slack agent needs to find a ride, it doesn't ask the LLM, does this man fit this wheelchair? Instead, the agent passes the vehicle and the wheelchair onto the ontology MCP. The MCP runs a deterministic validation. If the van's lift capacity is 350 pounds and wheelchair weighs around 350 pounds, the MCP returns a hard false. The LLM handles empathy, the intent, and the triage. The ontology handles the physics. This methodology approaches zero physical hallucinations. Let's talk technical execution. Lifeline deeply leverages all 3 core Slack technologies: the Slack agent builder for orchestration, the RTS API for ambient context, and the MCP for external data and ontology validation. But beyond the APIs, Lifeline applies rigorous distributed systems principle to NGO resource management. We treat shelter beds and volunteer vans like a high-throughput distributed ledger. First, deterministic routing and optimistic state locking. We don't just dispatch a volunteer. The agent decrements the shelter bed count in Airtable before notifying the volunteer. If the decrement fails, say another dispatcher claimed the last bed, the agent aborts the dispatch and requeries. No double booking, no race conditions. Furthermore, we enforce database level sorting and ontology pre-filtering, entirely eliminating temperature-based randomness from the LLM's selection process. Second, fault tolerance and graceful degradation. As the Google SRE book dictates, we design for failure. If the RTS API hits a rate limit and returns a 429 error, or the brittle bot crashes for some weird reason, Lifeline's agent builder logic gracefully degrades. It abandons the ambient context search, proceeds with the core database queries, and flags the audit log that ambient data was unavailable. The mission-critical dispatch never fails due to a non-critical network timeout. I'm going to show you the complete flow from intake to dispatch, including how the system enforces physical constraints that generic AI bots hallucinate. A frontline volunteer needs emergency housing for a family of 2 in Zone B. One person uses motorized wheelchair. In traditional setup, the dispatcher would spend 40 to 50 minutes cross-referencing Airtable and Google Sheet. I'm mentioning Lifeline here. Watch what happens next. The agent autonomously sweeps the workspace for ambient context using Slack's RTS API before even querying the databases. The agent is executing its reasoning loop. It's calling Slack search tool to check the channel logistic alerts for hazards like road closures or shelter outages. Then it queries the shelter roster in Airtable and the volunteer transport roster in Google Sheets. Here's the dispatch match card. Let me walk you through what's critical here. This is the breakthrough. Look at the routing logic section. The agent matched Lisa Patel with the heavy duty van. But notice it explicitly states that it rejected Dave Chen because his standard van's 300-pound lift cannot support a 350-pound motorized wheelchair. This isn't the LLM guessing. It is a deterministic ontology engine running inside the MCP server. The LLM doesn't know physics. It cannot calculate lift capacities and ramp widths. So we offloaded that validation to a symbolic reasoning layer. The ontology returns a hard boolean compatible or not, zero hallucinations. You can read more about it in the description page. And here's the ambient context. The agent autonomously searched logistic alerts and found that Mission Street in Zone B is closed due to a water main break. It used that data to filter out shelters on that street before returning the results. This is the RTS API in action, giving the agent awareness of physical world beyond just the databases. The dispatcher reviews the match, sees the routing logic and the ambient alert, and clicks confirm. Watch the UI state transition. The button is gone to prevent double clicks. The agent is now executing the state locking sequence, decrementing the shelter capacity in Airtable and marking the volunteer as dispatched in Google Sheets. And we are confirmed. The card mutates to the final state with a timestamp. This 3-phase state machine pending processing confirmed is designed for mobile-first one-thumb operation by frontline workers who are walking shelter floors and not sitting at desks. Let's verify the state change actually happened. Here's the Airtable base. Larkin Street View has 6 beds. Now it's at 4. The agent decremented it before dispatching the volunteer. That's optimistic state locking to prevent double booking. And here's the volunteer roster. Lisa Patel's status in available now column is false. Now the system didn't just generate it, it executed a real state change. Finally, the audit log. Every dispatch generates an immutable traceable record. Notice the permalink back to the original intake message, the exact capacity transition, the system state showing the ambient context, and the rejected candidates. This is enterprise grade compliance built into a Slack native workflow. The potential impact of Lifeline agent extends far beyond a single NGO. The United Nations Development Programme's digital strategy explicitly states that open source digital public goods are essential for equitable crisis response. By open sourcing our MCP ontology server, we are providing the foundational infrastructure for any non-profit to connect their legacy spreadsheets to Slack AI safely. The same way the Red Cross's open data kit ecosystem scaled across hundreds of organizations. Lifeline proves that agentic workflows aren't just about saving developer hours. By eliminating administrative context tax and by grounding AI in deterministic physical reality, we give volunteers their time back to do what they do best, and that's saving lives. We didn't just build a Slack app, we built an operational nervous system for crisis response. Thank you.